All right, this is 8-5 notes. All you're doing on this is factoring out your greatest common factor. So for number one, you have 24x plus 48y. So what I'm going to do here is I'm going to do kind of like my family tree and find all the numbers I can go on in 24 and decide on what prime numbers we have left over. So 24, I'm going to pick 3 and 8. For 8, I can do 2 and 4. 4, I can do 2 and 2. Okay, and see here I have just this x, so I'm going to rewrite that just one x. Okay, and then I have 48, and then I'm going to work on, so 48 I can do 6 and 8. Here I can do 2 and 3. Here I can do 2 and 4, and then we can do 2 and 2. And then again, I just have this variable y. There's only one of them, so I'm just going to write down y one time. Okay, now here's what you're going to do. You're going to go ahead and kind of find matching numbers. So here I have a 3. So I'm going to look underneath the 48 and see if I can find a 3. And I do. So I'm going to write that down. I'm going to cross that off. Okay, and then I have a 2 here. So whatever I have on the left side, I need to find on the right side. So times 2, and I'm going to cross that off. Then I have another 2 and another 2. So I'm going to go ahead, write that down, cross that off. And then I have another 2 and another 2. So times 2, write that down, cross it off. And that's all that I have left on the outside. Okay, so there's nothing else. If you look again up here, your x and y, there's something that's in common that I can pull out. So I'm going to rewrite what I have left over. Okay, so what I have left over after I pulled everything out that was common is here I just have this x. Okay, that's all that I have left over. So if it helps, you can cross it off so that you know. And then over here, what I have left over is I have a 2 and a y. Okay, so we're going to go ahead and simplify this. And then to simplify it, we're going to do 3 times 2, which is 6. 6 times 2 is 12. 12 times 2 is 24. So 24 times x plus 2y is our final answer. And to check it, just go ahead and distribute the 24 to both sides, and you should get what you started off with in the problem. Okay, so let's go on to number 2. Number 2, we have 3 of them. So first I'm going to go ahead and start with 30. So I'm going to do 10 and 3, and then I'm going to do 2 and 5. Okay, I have 1m. P squared means I have 2 p's. Right, here in the middle I have 2 m's and 1 p. And then here at the end I have 6, which I can break down into 2 and 3, and I have a p. Okay, so now I'm going to find something that is common in all of these. So when I look at my numbers, since I have no numbers here in the middle, all I have is like a 1. Okay, there's nothing I can pull out because there's a 1. 1 has no numbers there for me to pull out besides 1. So I can't even do anything with my numbers. And then let me look at my letters, okay, my variables. So I see that the first and second term have an m I can pull out, but all 3 have to have it. So the only thing that I see that all 3 have in common is they all have this p that I can pull out. So I'm going to write that down, and I'm going to cross off the p. There's nothing else in here that I can pull out, so I'm going to write what I had. I didn't pull out any numbers, so I'm still left with a 30. I have an m left over and a p left over. Okay, in the middle, I pulled out the p, so all I have left is m squared. And for the last piece, I pulled out the p. All I have left was the minus 6. And again, you can multiply this out to make sure you have the right answer. Okay, number 3. So for number 3, I'm going to do the same thing I've been doing. So here I have Q, 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 and Q. So right now, I know that there is not going to be any numbers I can pull out because this right here is a 1. And so, you can't have a 2 and a 3 or a 5 or anything like that to pull out. So I'm not even going to bother doing my little family tree here with the 18. All I'm going to worry about are my variables. So I have 3 Q's and I have 1 Q. So the only thing I can pull out of all 3 of these is this Q. So Q, Q, and a Q. So I'm going to pull that out. So what I have left then on the inside, this first part says I pulled 1 out. I have 1, 2, 3 left over. So it's Q to the 3rd power. Then I have minus 18. I pulled 1 out, so I have 1, 2 left over. So Q squared. And the last one, I pulled the Q out. All I have left is just the 22. All right. Number 4. Okay, so number 4. Now some of y'all can get pretty good at this and say, okay, I know both these have a 3 in common that I can pull out, and they both have an x in common and I can pull out. So some of y'all can go like this. All right, I'm going to pull this 3x out so I have 3x minus 1 left over. Okay, if you can do that, that's great. Some kids can't do it, and you have to break it down. So I'm going to break it down for you. This 9 is 3 and 3, and then you have 2 x's. Here is just a 1 and 3, and you have an x. Okay, I have a 3 in common that I can write down and cross off. I have an x in common I can write down and cross off, and there's nothing else. So what I have left on the inside is I have a 3x here, because there's a 3 and there's x left over, and for the right piece all I have left is a 1, and that is it. Alright, number 5. So looking at number 5, I'm going to go ahead. Some of y'all can say, oh, these are all even numbers. I'm going to pull a 2 out. And so some of y'all can say, okay, here's a 2. So I have 2m left over. 6 divided by 2 is 3, so I have 3 p's left over. 8 divided by 2 is 4, so I have mp left over. Some of y'all can see this and do that. If you can do that, that's great. Okay, if you can say, all right, well, I only have an m on the first one, a p on the second term, and an mp on the third, so there's nothing I can pull out that all of them have in common, then that's fine. If you need to, though, here's how, like, the work to show you why this works. So 4 is 2 and 2, and you have 1 m. 6 is 2 times 3, and you have 1 p. 8 would be 2 times 4, and that's 2 and 2, and then this is just mp. Okay, so in order to pull something out, every single thing has to have it. So the 4 has a 2, the 6 has a 2, and the 8 has a 2. So I can pull that out. Okay, there's nothing else that each one of those things have in common that I can pull out. So what I'm left here is a 2m. In the middle, I have a 3p. At the end, I have a minus. 2 times 2 is 4, and I have mp together. Alright, so if you notice, that is exactly what I wrote up here. Because I can see that they're all even, I can pull that 2 out. So if you're able to do that, then you can go ahead and do that. Alright, number 6. So see, the way I see this is I already know that 45 is divisible by 15, and I see that the greatest, I have 2 r's I can pull out. So I can already tell you right now the answer is going to be 15. Oh, I forgot my r. And I can pull out an r squared. So that would leave me with 3r minus 1. Now I'm going to show you how to do this with your family tree, though, in case you don't understand how I was able to do that in my head. Okay, so here 45 is 3 and 15. 15 is 3 and 5. You have 3 r's. Here this 15 is 3 and 5, and you have 2 r's. Okay, in order to pull anything out, it has to be on the left side and on the right side. Okay, so I see a 3 and a 3 that I can pull out, so that's gone, times a 5 and a 5 I can pull out, and that's all that I have for my numbers. Now my r's, there's an r and an r I can pull out, okay, and there's another r and another r I can pull out. So now I'm going to write down what I have left over. So what I have left over here is just a 3 and an r, so 3r, minus, I don't have anything left over here on the right side, so I'm just going to put 1. Okay, so now I'm going to simplify this. 3 times 5 is 15. Since you have 2 r's, it's r squared, and then we have 3r minus 1. Alright, okay, halfway done. So number 7. For this one, 14 would be 2 times 7, and you have 3 t's. 42 would be 6 times 7. 6 is 2 and 3, and you have 5 t's, so 1, 2, 3, 4, 5. 49 is 7 times 7, and you have 4 t's. Okay, so let me go ahead and pull out what I have. So I have a 7, and a 7, so I can pull that out. I would be able to pull out a 2 if the 49 had a 2 on there, but since it doesn't, I can't even pull out a 2. So let me go now into my variables, my letters. So I have, I know I can pull out 1 t. Each one of those has 1 t, so I'm going to cross that out so I know I used it. Another t I can pull out, so I'm going to cross that off. And another t I can pull out. Write down, cross it off. Okay, so now I'm going to look at what I have left over. So here for the first part, I just have a 2. minus, here in the middle part I have 2 times 3, which is 6, and I have 2 t's, so that's t squared, minus, here I have a 7 and a t, so 7t. Okay, now I'm going to simplify this. Since I have 3 t's out here, I know that's t cubed, and then I have 2 minus 6t squared minus 7t. Now for these, you do not have to write these in standard form. Okay, when you pull this stuff out, you don't have to write it in standard form because the problem originally was not in standard form. Okay, here we go, number 8. So see, I am able to look at this and say I can pull out 2 p's and I can pull out an 11. If you are really good with your like multiplication facts and all that, then you can do this. You can say, all right, I know all these numbers are divisible by 11. My greatest exponent for the p is 2. So that will leave me with 55 divided by 11 is 5. And then I just have no p's left because I took out 2 of them. Here I have minus 5. Or sorry, not minus 5. Here I only have minus 1 because I took out the 11. And we have, I took out 2p, so I have 2 left. Here I have 44 divided by 11, which is 4. Since I took out 2 p's, I would only have 3 left. Now, if you can't do that and see that in your head, that's completely fine. I'm going to show you now how to work this out, kind of, I would say, the long way. So here, this is 5 times 11, and you have 2 p's. Here, this is just 1 times 11, and you have 4 p's. Here, this is 4 times 11, and you have 5 p's. Okay, so now you, in order to pull something out, you have to have it in every single one. It has to be a common factor. So what I see that every single one has is an 11. So I'm going to write that down. And now I have a 5, a 1, and a 4, so there's nothing else that's in common. Now I'm going to look at my p's. Here's a p, here's a p, here's a p. Write it down, cross it off. And if you want to cross those 11s off, you can. All right, another p, another p, another p. Write it down, cross it off. And I can't pull out any more p's because I took all of them out of the first one. So what I have left over on the inside, so I have a 5 right here. So there's a 5. I have 2 p's. I have a 1 if you want to put the 1, and I have 2 p's left. And then I have a 4, and I have 1, 2, 3 p's left. Okay, so we can simplify this. You have 11p squared, 5 minus p squared, plus 4p cubed. And again, you don't have to write it in standard form because the original problem is not written in standard form. All right, okay, number 9. So right now, I know I can't do any numbers. As soon as you see that you have a 1, there's no number you can pull out of all 3 of those except for 1. You can't pull out of a 2 out of a 1. If you did your family tree, all you have here on this 1 is just 1 and 1. So there's really nothing that you can do number-wise. So the only thing that I'm going to do then is I'm going to look at my y's. I have 3 y's here, I have 2 y's here, and I have 1 y. So whenever I look at pulling something out that all 3 have, they all have a y that I can pull out. So I'm going to write down my y, cross that off, and I'm going to write down what I have left over. So here I had a 14, and I only have 2 y's, so that's y squared. Here I have minus 28. I only have 1 y, so there's y. And in the back side, I just have that 1 left over because I pulled the y out. And that's it. That's all that you can do. Okay, number 10. So the first thing that I see is that there's an x in each one I can pull out, and all these numbers are divisible by 4. So if you're pretty good with your multiplication facts, you can say, all right, well, let's pull out a 4 and an x. So that leaves a 1 in front because I pulled all that out. 12 divided by 4 is 3. Since I pulled out 1x, I only have 1 left over. 16 divided by 4 is 4. Since I pulled 1x out, I only have 2 left over. Okay, if you're good at your multiplication, like I said, then you can do that. If not, here's how we do this. 4 is 2 and 2, and you have 1x. 12, I can do that 3 and 4, which 4 is 2 and 2, and we have 2 x's. 16, we can do 4 and 4, which is 2 and 2, and we have 3 x's. Okay, you're going to pull out what all 3 have in common. Well, first let's start with numbers. They all have a 2 I can pull out. So there's a 2. Cross it off so you know you're done with it. They all have another 2 in common. Write it down, cross them off. Okay, and that's it because my 4 is done. There's no more numbers in my 4 to pull out. So now I'm going to look at my variables. So I have an x, an x, and an x I can pull out and mark it off. And there's nothing else because everything in that first term I have completely used. So what I have left over, I just have a 1 for this first part. In the next part, my middle, I have a 3 right here and an x. So here's my 3x. And the last piece, I have a 2, an x, and an x. Well, 2 times 2 is 4. Actually, I'm just going to write down right now. We have a 2 and a 2 and an x and an x. Okay, so now I'm going to write my final answer. 2 times 2 is 4, and you have an x. And you have 1 plus 3x. 2 times 2 is 4. X times x is x squared. And that's your final answer. And again, you can always multiply this out to see if it will give you what you started with. Okay, 2 more. Actually, we decided we're not going to do 11 and 12, I don't think. Nope, yeah, we're not doing 11 or 12. We can skip over those. So then that's going to be it for your notes because there's not on the back side. So that's it for 8-5. So this should be able to help you now on your ALEKS homework.